Question 1.6. 4-point charges, 2 microcoulomb, minus 5 microcoulomb, again 2 microcoulomb, minus 5 microcoulomb, are located at the corners of a square ABCD. ABCD. Mostly give names in anti-clockwise manner when it is not given. So I have given in anti-clockwise manner. Then here the side of the square is 10 centimeter. So let us assume this is 10 centimeter. What is the force on 1 microcoulomb placed at the center? So here you can see there is 1 microcoulomb charge is placed. You can carefully observe this, right, and then we will solve, right. So here you can see there is a square whose side is of 10 centimeter, and there are 4 vertices, and on each vertices or at each corner there is a charge which is labeled in the figure. Now here there is one positive charge, right. Here you can see plus 1 microcoulomb which is placed at the center. Now what will be the force on this 1 microcoulomb, positive 1 microcoulomb charge by this? See, this is also 2 microcoulomb and which is positive. So positive repel. So this positive charge at corner A will repel this charge in this direction here. So it repels in this direction which is labeled here. So force on 1 microcoulomb charge placed at the center is Fa. So here the direction Fa is labeled, right. Similarly, this charge of 2 microcoulomb placed at corners is also positive. So positive repel. So it will exert force this 1 microcoulomb charge in this direction, right. So it is Fc. So here you can see Fa and Fc are in opposite direction. That is, the angle between them is 180. So the net force along this line can be calculated by Fa minus Fc, that we will see later. Right now just I am explaining. Now if we talk about this charge at B which is negative, and the charge at this center 1 microcoulomb is positive. So what will happen? It will pull this negative charge minus 5 microcoulomb will pull 1 microcoulomb towards it, okay, because it will attract. One is negative, one is positive. Similarly, the charge at corner D is also negative, minus 5 microcoulomb. So it will also pull this charge in this direction because it is negative. So negative attracts positive, okay. So this is the picture that you can see here. Now let us put it mathematically. So here when we want to use Coulomb's law, right. So what is the Coulomb's law? F is equals to K Q1 Q2 by R square, where R is the distance between the two charges. So in all the cases, here there is a and here we have 1 microcoulomb. So the distance is half of the diagonal. Similarly, if we talk about B and O, then the force applied by B on O, that is on 1 microcoulomb, is towards B, and the distance, the R, is also half of this diagonal. So in all these 4 cases, the R become half of the diagonal. So we have to find the length of the diagonal, then we have to divide by 2. So here we have square whose length is L. So you can use Pythagoras theorem and you can obtain this hypotenuse, right. So this is, we can use Pythagoras theorem and we can obtain hypotenuse. So this hypotenuse is actually the diagonal of the square, and we want R, that is we want this length, half length. So this is if this is L, right, the sides are L, then using the hypotenuse, using the Pythagoras theorem, we can obtain this diagonal to be root 2L, right. It is simple, L square plus L square under root, right. I am using a very simple maths, right. There is no rocket science, you can understand this. So the half of the, so what we can get is, this is root 2L. So what will be the half of this? This half I want. So it is root 2L by 2, right, because we need to divide it by 2. Now it is root 2L, and 2 I can write as root 2 into root 2. Root 2 into root 2 is 2. So root 2 cancel. So the length of the diagonal will be L by root 2, half of the diagonal. The length of half of the diagonal is L by root 2. So here I have explained this. L, that is the side length is 10 centimeter, diagonal is root 2L. Now we want this AO, then we want BO, then we want CO and DO. So AO, BO, CO and DO, they are half of the diagonal, and half of the diagonal we have obtained as L by root 2. And what is L? It is 10 centimeter. So as it is 10 centimeter, so we can write it as 10 by root 2. And again, if you solve this, it is 5 into 2 by root 2. Again you can solve this and you will get phi root 2. So the length of the diagonal is half of the diagonal, that is AO, BO, CO and DO is phi root 2 centimeter. Right, it is not a lengthy question, but what I am explaining is lengthy. I am going into the depth, so those students who are bad at maths can understand this. Now next is, now I want to find the force exerted by the charge A, force exerted by charge A on this charge, and they will repel, right, because both are positive. So what is the Coulomb's equation? K q1 q2 by r square. So here you can see force applied by A on q naught is equals to K qa q naught, that is the q naught I am writing because q the charge which is at the center, it is divided by AO square, where AO is our r. So I am just putting the value. So K is 9 into 10 raised to 9, QA, the charge at A is 2 into 10 raised to minus 6, the charge at the center here is 10 raised to minus 6, that is 1 microcoulomb, and AO is 5 root 2 into 10 raised to minus 2 square. So this becomes 3.6 Newton. You can see the direction of the force. What is the direction of the force? The direction of force is labeled here, which is FA, and it is along O to C, right? So the direction of the force is OC. Similarly, you can check for force by C, it is K, QC, Q naught. Now I am not going in depth, right? Now you can understand this. So I have just put all the values here. It is value of 9, then QC, it is 2 microcoulomb, then 1 microcoulomb, then again and the distance R, and again we are getting the value 3.6, and as again C and the charge at center both are positive, they will repel. So here you can see that it is along OA. So OA and OC are opposite in direction, right? So these forces are equal and opposite in direction, so their summation will be 0, right? So this force, the summation of these two force F and FC is 0. Now let us talk about the force on charge at O due to charge at B and charge at D. So the force on charge at O due to charge at B is FB is equals to K QB QO by BO square. Again I am just putting the value of K, value of charge at B, and value of charge at center, again value of R, that is OB. So if you calculate, you will get 9 Newton. Similarly, right, you can calculate the force exerted by this charge D on the charge at center, again you will get 9 Newton. Now if we trace their direction, then these two charges, right, which is given in the question, the charges at B and the charge at D both are negative, so they will pull. So FD is along OD and FB, force by B, is along OB. So both are again equal and opposite, so they cancel each other and the net force will be 0. Now what is the total force? So the total force is the addition of all the forces. So if I add these two force, FA, then FC, then FB and FD, so I will get 0 because FA and FC is 0 and FB and FD, their vector sum is 0. Okay, so I hope you are very clear with this one.